Hello and welcome. Hi, I'm Dave, and today we're talking about functional programming, specifically compose and pipe functions that are frequently used in functional programming. Now, today's tutorial is an advanced JavaScript tutorial, so you'll want to already be familiar with at least pure functions and currying functions. And if you're not, I'm going to put links to my tutorials for those in the description below. Okay, let's get started with pipe and compose functions. Today we're talking about functional programming. If you've heard of functional programming, you know it works with pure functions, and they're usually tiny, small, composable functions. And composable is what we're talking about today, is how do we link together these small functions? Well, functional programming often uses what are called pipe and compose functions, and those are higher order functions. A higher order function is any function which takes a function as an argument and it returns a function, or it does both, which it takes it as an argument and returns a function. Let's look at how a compose function works. I'm not going to make a compose function. We will walk through essentially how it works first before we make one. But what we need to start with are several small unary, and that means one parameter, functions. And I usually say parameter. I know the definition above here said argument, but the word argument or arguments and parameter or parameters are often interchangeable. Okay, so we're starting with three small functions. We've got add 2, subtract 1, multiply by 5. They're unary functions. They all just receive one parameter. And from there, we're going to execute these functions. But notice how the functions execute from inside to outside and right to left. You may have done this with a function before, because add 2 is passed the first parameter, which is a number 4, and then it returns the result. And the result is a number, so we can just plug it in to the parameter for subtract 1. And subtract 1 is just plugged in as the parameter for multiply by 5. So notice how this executes from the inside to the outside. And if this was nested, if we were writing the functions out, it would look like a staircase. But we're going right to left instead of left to right. So it starts with add 2 and it ends with multiply by 5. And then we can log the result to the console. So let's take a look. And we get 25 in the console. And that's what we'd expect if you do the math. From there, let's note that the above is not a compose function. I was just showing how a compose function would execute functions, because it does go from right to left and it does essentially work its way from the inside to the outside. So now let's make our own compose function. Before we make our own compose and pipe functions, I'd like to note that the libraries Ramda.js and Lodash both have their own built-in compose and pipe functions, and note that Lodash calls pipe flow. So let's look at how these work. It uses the higher order function reduce and takes a list of values and applies a function to each of those values, eventually accumulating a single result. And if you think back to what we did with those three simple functions before, that's essentially what we did. We just didn't compile a list. We accumulated the result. So now let's write our compose function. And to get the compose order from right to left, in other words, inside to out, we need to use reduce right instead of reduce. But you can see we set compose equal to a function, and this function is curried. If you remember what currying is and have watched my currying tutorial, of course I'll give a link below in the description, but it accepts a list of functions, and then there is a value that is received. So this is a function and this is a function, and that's why it's curried. And here on the functions we call reduce right, and if you're familiar with reduce, you'll know how reduce works, but it works just as described above. It takes a list of values and applies a function to each of those values in this regard, and therefore it accumulates a single result at the end. I also have a tutorial on higher order functions, and if those are new to you, you should probably stop right now and learn more about higher order functions first. I'll give a link below to that as well. Okay, with our compose function defined, we can call it. And we can set comp result equal to compose and we pass in our 3 previous functions. And notice we start with multiply by 5 on the left because the first function that will be called is add 2. It's going to start from the right and work its way left. And then we're passing a parameter here at the very end. So we're calling it into action immediately. We're immediately invoking the function, if you will. And let's go ahead and log that to the console. And when I save this, we get 25, just as we did before, but now we're using our compose function. Now, what about pipe? Well, there is something to do with that, and that is if you don't like reading from right to left, pipe essentially changes the order. It doesn't use reduce right when we create our own, it just uses reduce. And so we can list the functions in the order from left to right that we want to use them in. And that's why I like using pipe more than I like using a compose function. Once again, Lodash, if you use the built-in function in that library, it is called flow and not pipe. But these functions are typically referred to as compose and pipe, or pipeline I have also seen. So here we can set pipe result equal to add 2 on the left, then subtract 1, then multiply by 5, and once again we'll immediately invoke our function, and let's log the result. And I'll save, and since we passed in a 5 instead of a 4, the result is now 30 in the console. You will also often see the functions on separate lines, whether you're using a compose or a pipe function. So now I'm setting this equal to pipe result 2, but it's essentially the exact same function, and I'm once again providing a parameter immediately, so it's invoked, and now we're providing the parameter 6. Let's go ahead and log this to the console, and you can see the result is 35. The examples we've been looking at use a pointer-free style, and with a unary function, you don't see the parameter passed between each function. You just see the parameter added at the end of the compose or pipe function if we're immediately invoking the function. It doesn't have to be that way, and I'll show you an example of that as well. But now let's look at some examples to where if you had possibly more than one parameter, or you're not working with a unary function. And so here's an example with that second parameter, and I've got divide by, but I don't say divide by 2 or divide by 5. So this function requires 2 parameters, the divisor and then the number that's being divided. And you can see it just returns the result. So if we create a pipe here, look at how we provide divide by. In this instance, that same pointer-free x variable that is being passed between each of these functions, which is the result, so it would be the result of multiply by 5 here would be passed to x. Then we use an anonymous function and we call divide by, and we just provide the number 2 here, and then x will go into the function as well. And we can go ahead and log this, and that's how we would use a function with more than one parameter in our pipe or compose function. But you could curry the divide by function to create a custom unary function because you're already hard coding the number 2 here. So if you write divide by, and I'll call it div by, just so I don't have a duplicate definition, then we curry the function, and the first parameter it receives is the divisor. The second parameter it receives is the number to be divided. So it's essentially the same function, but it's curried, so it expects to receive 2 parameters at different times. And this allows us to create a partially applied function. So we can create a custom unary function called divide by 2 that's equal to our div by function that has already received the first parameter of 2. By doing that, let's look at this pipe result here, and you can see now we just put divide by 2 and it works as all the other unary functions. Once again, I call it with 5 immediately afterwards, so we're immediately invoking this, and I'll go ahead and log this to the console. Let's look at some other simple examples that are not math functions. I'm going to start out with a paragraph of lorem ipsum, and here we're just going to count the words in the paragraph. So I've got my variable lorem right here, and now I'm going to define a couple of functions. I've got split on space, and that's simply calling split on a string, and it's looking for each space in the paragraphs or paragraph. And then we're going to go ahead and count how many words we have after splitting the full string. And that should give us a basic word count for the paragraph. So if we were to create a pipe function and use it for word count, first we would call split on space, and then we would call count. Notice how I'm not immediately invoking the pipe function right now, because you don't have to do that. I did that in the previous examples. But we can go ahead and console log and call word count now, because word count is a function, and pass in lorem. So let's save this. Word count essentially has our pipe function. So we don't have to call it immediately, or it's not immediately invoked unless we want to by passing the parameter at the end. And here you can see we get 60 words in our paragraph. Now the pipe function is also reusable. So I've just got a variable here named EGBDF, which stands for every good boy does fine. If you took music courses, you may have learned that sentence. And now we can call word count on the EGBDF variable as well. So I'll save, and you can see we get a result of 5 in the console. Let's look at combining processes too. So we're going to check for a palindrome, which is a classic programming challenge. And a palindrome is spelled the same forwards and backwards once you send everything to lowercase and remove the spaces. So you can see taco cat is definitely a palindrome. We can just visually see this. So is UFO tofu. But my name, Dave, that's not a palindrome. So we're going to check each one of these, but we need to combine processes to do so. And we can make little functions along the way that will help us, and then we'll pipe those functions together. So we'll start out with these little functions. And really, I'm just taking some string methods and turning them into my own functions for this example. So I've got split, join, lower, and reverse. And you can see how the reverse is an array method. From there, I can create a pipe to lowercase and remove the spaces of my forward word that is going to be spelled the forward way. So this would spell Dave all lowercase, for example. And now we can use that pipe again. So let's look at the reverse pipe, and notice I've nested in the forward pipe right into this reverse pipe. So we have a nested pipe function, and that's totally doable. There's nothing wrong with that at all. So now when we call the comparison, and I'll log these to the console, let's compare pal1 is taco cat, and pal2 is UFO tofu, and pal3 is my name. So we'll go ahead and save and look at the console. We get true on the first two and false on the last one. Our functions are working correctly, and now you know you can use a nested pipe function. In object-oriented programming, objects are often passed around and mutated by different functions. Unfortunately, then you have to know the history of everything that has happened to that object, sometimes to find a bug, and that also makes it harder to test. However, in functional programming, state mutation or object mutation or just data mutation is really not allowed. That's why we want pure functions. And therefore, you need to clone or copy objects and arrays and not mutate those objects. So often, times to solve this problem, we need a clone function or a copy function, and that could be within our pipe or compose functions that we're making. So let's look at an example or two of that. And we'll start with 3 different approaches actually. So not just 1 or 2, but 3. Here's the first one. We could clone the object before an impure function mutates it. And you'll see what I mean by this. So we'll start with a score object that just has home and away score, and they're both 0. And then we've got our shallow clone function. Now I do have a separate tutorial on making shallow copies and deep copies, and you'll learn how to make those functions in that tutorial. So I'll link to it below, and it should pop up above right now as well. So here's our shallow clone, and it just checks to see if the object is an array. And if it is, it returns a new array. So it's a shallow copy, and it has copied in the previous array. Likewise, if it's an object, if it's not an array, it should be an object, and then it passes in a shallow copy of that object. And that's what it will return. So the next function in the pipe or compose functions that we're pulling together would be increment home, and it expects an object, so it should be receiving the clone, or the copy if you will, and not the original. So it will mutate the object it receives right here, setting object.home and incrementing it by 1, whatever the value is. So in this case, if it's 0, it would be 1 when it's finished. If we were to test this function by itself, it's not pure because it does mutate the object. But by putting it in a pipe with shallow clone in front of it, it's going to receive a clone of the original object that we call the pipe function with, and therefore this is a possibility. Let's go ahead and create that pipe, and I'm calling it home score, and you can see I'm calling shallow clone and then increment home, and then we might have other functions that receive the object as well. And let's go ahead and log the results here. So we're going to call the home score pipe on the score object, and then we'll look at the score object itself. Remember, home score is going to return an object when it's finished, so we'll see if those look alike. And then we'll also use a strict comparison to see if those objects are identical or if we've created a new object and mutated the new object. So when I save this, we'll look to the console. You can see after we call the home score function, we get home1 away 0. But our original score object has not been mutated. It's home 0, away 0, and so they are not equal. Now the positive of this approach is there are fewer function calls because we're only calling this clone function once in the entire chain of functions within our pipe. But the negative is we have to create impure functions, and that creates testing difficulties and possibly debugging difficulties. And impure functions are not really what we want, if possible, in functional programming. So this may not be the way to go. The second approach is to curry the function, which will create a partial that is unary for your pipe or compose function. And so when we look at this, we'll define our function increment just a little bit differently. And of course, I'll put a b behind it just so it's a separate function. And I'm also using the keyword let, which is important. And it's with this curried function, I'm passing in the clone function as the first parameter. And you can tell it's curried because here's a function call and here's a function call. And then we pass in the object as the second parameter. Inside the function now, we create a new object and we call the clone function that is passed in. And here is still mutation on the new object, but that's okay because it's happening to the new object and not the original object that we passed in. And then we return the new object. And we're not quite finished after that definition. Then this is why we use the keyword let. Then we need to take our increment home b and set it equal to increment home b and pass in that clone function. So this is making a partial through currying. And after that, we can go ahead and create our pipe, and we just have to pretend there's some other functions in the pipe, or if we wanted to use compose, either way. And this function will work here now as a unary function. And so we can call our home score b with the score object, and we'll also just pass the score object to the console once again so we can compare. And I'll save. And we get home1 away 0, and still the score object is unmutated. The pure function with clear dependencies created through currying makes this a great choice. And out of the three approaches, this may be my favorite. But the negative is there's more calls to the cloning function, because if you need to do something else with an object and something else with an object, and you're creating all of these that may mutate objects or arrays, then you need to pass in that clone function to each one of those. However, this does meet the definition of a pure function, and it does allow for easier debugging and testing, and that's what functional programming is all about. And the third and final approach is a lot like the second, but we do not curry the function. We do insert the clone function as a dependency though. So let's take a look at this function, and it looks more like we would expect from a normal function where it just receives two parameters, the object and the clone function. And then inside the body of the function looks much like the curried function, basically identical here for these three lines. From there, we can create our home score C with a pipe. And you can see now how we call this increment home C function. And we're just passing in x. There's, say, possibly a function before it. Whatever the unary function returns is going to be x, and it should be an object or an array here. And then we explicitly pass in our shallow clone function right here inside of the pipe. And so this would be another way to handle this without creating a partial, because you can do this inside of a pipe or compose function. So from here, let's go ahead and call home score C and pass in the score object and compare the original score object again. And if we look at the console, once again, we get our new object that has home 1, away 0, and the original is still unmutated. So the positive aspects of this are we get a pure function with clear dependencies. And the negative part is non-unary functions in your pipe and compose chain, and they just don't look as good and they're a little harder to work with, but it's not a huge negative. So if you wanted to go this route, that would be fine. I kind of lean towards the second one, and that was the curried function that creates a partial, and then it's unary inside the pipe or compose, just like the other functions are. So I hope you now know how to create your own pipe and compose functions, and you're curious about functional programming, because even if you don't strictly adhere to it, following some of the functional programming principles can keep your code clean and dry. Of course, that means don't repeat yourself. Hey, thank you guys for watching and subscribing. I sincerely appreciate it, and thank you for helping my channel grow. I'll see you guys next time.